Hello, welcome once again to episode number 5 on the tutorial on coordinate geometry 1, the straight line. Here we want to also apply the concept of the length of a line, the distance of a line, or the magnitude of a line in determining the vertices of a right triangle. So we are to determine whether the point 8 minus 8 1 minus 2 9 and 10 0 form the vertices of a right angle triangle. We know a right angle triangle will have a 90 degrees, hypotenuse, opposite, adjacent, where we apply the concept of Pythagoras theorem. So if we use the concept of the distance formula, finding the length of all the lines, if they form a Pythagoras word triplet, then we can say that these points are actually the vertices of that right angle triangle. So let's see how we can do that. So let's say we don't have any other point. So let me say point A should be minus 8, 1. Point B should be minus 2, 9. And point C should be 10 and 0. So if you have your right angle triangle in this form, I can have A, B, C. I want to know the length of AB, BC, and AC. By recall, we know that the length of AB will be equals to the square root of x2 minus x1 squared y2 y1 squared. By the recall, that is the formula for finding the distance of a point. So let's begin with AB. Now when I pick AB, I am going to say that this is the first x, so x1, the first y, y1, second x, x2, second y. These are the designation of the x and the y we have. So x1, x2, y1, y2 will pick the values from the point. So this is going to be beginning from here. Minus 2 is the first one. So I have minus 2 as x2, then x1. Where is it? That will be minus 8, the all square. You see, there's a minus 8. So we indicate the minus 8, which is different from the negative sign here, which is different from the minus sign. This is a negative sign, the minus sign. So this minus is from the formula. This negative is negative from the coordinate of the point. All right. Then your y2 is going to be 9 minus 1. So I have 9 minus 1 all square. Describe the y2 minus what? y1. What do I get? This is going to be negative, negative, positive. So minus 2 plus 8, which is just like 8 minus 2. That will give us 6. Don't forget the square. 9 minus 1 will be 8, right? Then we square that. Okay, let's go along here and have 36 plus 64. If you find the square of 6, 36, of 8, 64. 30 plus 60, 90 plus 10, so we have 100. So I have 100. If I like, I maintain the 100, or I can still say what? 100 is going to be 10 units. We don't even need to, because we are looking for the triplet. So I can leave it in this form. Then let's go to AB. So let's go to BC. Let's pick the length of BC following the same formula. I am going to now change the designation BC. So I don't need these names here. B is the first point. So this is your x1, y1, x2, y2. So we can now say that x2 will be 10 minus negative 2. So 10 minus negative 2 all squared. The minus 2 is part of the sign. Then we go to 0, right? Plus 0 minus 9. So I have 9 all squared. I guess in this place, negative will become positive. So I'll be having 10 plus 2, and that will be 12. Then this is going to be 0 minus 9 will be minus 9. So I have my minus 9 all squared. I bet I'll have 144 as in the square of 12. Then 81 as in the square of 9. Don't forget it's negative 9 times negative 9. That gives you a positive 81. So if I pick 60 from here, I'll be having 204. So I'll having 225. 225 as the root. I can get my 15 unit, or I can leave it as the root of 225. So now the last one is to find AC. Let's find the AC and compare. So for AC, following the same formula, this is going to be A is beginning. So this is going to be your x1, y1. Y is the C. The C is here. So I'll be having x2, y2. So x2 will be 10 minus negative 8. So 10 minus negative 8 all square. This is going to be y2. 0 minus y1. That will be 1 all square. So let's go. This will be giving you plus. So 18 square plus negative 1 all square. And from here, if we find the root, 18 times 18 will be 324. Negative 1 times negative 1 will be 1. So that will be giving us the root of 325. And 325 is not a perfect square. So we can maintain it. So maintaining this one and this one will give us what we are looking for. So now we can say that by Pythagoras theorem, we know that the longest side from here is AC. So our AC squared equals to AB squared plus BC squared. If this is proven, then we can say that they are the vertices. So let's see. AC is what we have as what? The root of 325 all squared. The square is coming from here. AB, we have it to be the root of, where is it? Okay, 100 all square plus BC, which is the root of 225 all square. The square will cancel the root, so you'll be left with 325 equals to 100 plus 225. Is that true? If you add 100 to this, we're having this. So we can say that the vertices. So therefore, the point from the vertices of the right triangle. So we are looking for whether the points are forming the vertices of the right angle, and it is well proven. The only way you can prove it is finding the length of all the sides. As long as the length form a Pythagoras what? Triplet. Meaning if you find the square of the longer side equals to the square of the sum of the two shorter side, you are going to get your vertices being part of the right angle triangle. Thanks for watching. Like, share, and comment. Bye-bye.